Part 1. Structuring your smart contract. In Part 1, we're going to talk about the ERC 721 standard, and we're going to deploy a contract to the Rinkeby network. But first, some inspiration. Let's check out the CryptoKitties storefront on OpenSea to get a sense of where we're headed with all this. The goal of this tutorial is to help you progress along the path from wherever you are now toward the point where you've got a storefront like this up and running on OpenSea. Let's take a look at docs.opensea.io. We've got a few options here. You can create your own marketplace, run your own crowd sale, build a custom app with the SDK, and we've also got some documentation on our API. Let's select the first option. So in this tutorial, we're going to build a non-fungible token on the Ethereum blockchain, and that means using the ERC 721 standard. Let's take a look at what the ERC 721 standard is. It basically lays out a certain set of criteria that you have to meet in order to be compliant. If you can do those things, then other apps will know how to treat you. They'll say, okay, this token has transfer, it has transfer from, it has approval. Therefore, I can treat it as an ERC 721. You can do other things on top of that, but the ERC 721 standard sets out a baseline. At OpenSea, we like the OpenZeppelin version of ERC 721, which is what the OpenSea Creatures contract that we're working with is based on. You can find the link in the description below. Now let's check out the repository. This is OpenSea Creatures. This is a simple repo that we set up to help developers get a sense of the process for creating a non-fungible token and getting set up on OpenSea. So let's clone it locally and see what we've got. There's a lot of contracts here, but our main focus is going to be on Creature. Creature inherits from tradable ERC 721 token. And let's take a look at package.json. It's pretty standard stuff. There's going to be a couple points that we got to focus on, but just wanted to get a peek early. And this is the truffle.js file. This is where you handle the Ethereum specific part of development. We'll get back to this later when it's pertinent, but just wanted to take a peek. If you've done Ethereum development before, a lot of this is going to look familiar to you. Let's take a look at creature.solidity. Not a lot happening here. Most of it's powered by tradable ERC 721, so let's take a look at that next. Okay, so this is where the real guts are, and this inherits from ERC 721 full, which is an OpenZeppelin contract, but what sets this apart really is the proxy registry stuff and this mint2 function. Mint2 is going to do a lot of work for us in the course of this process. So in order for this to work smoothly, work at all, we're going to need to use a specific version of NPM and a specific version of Node. So if you haven't done this, you're going to want to install NPM at 5.6.0. Let's take a look at the package.json. We need NPM to be 5.6.x, which means that if you have 5.6 point something else, you're fine. But we're also going to need, this is especially important, to use 8.11.2. So the command for that is npm use 8.11.2. And if you can see that you're on 8.11.2 and 5.6.x, you're going to be good to go. So now we're ready to npm install. It's going to take a while, so let's cut to the chase. Now we've got our Node modules installed. Let's pop back over to the tutorial and identify our next task. Okay, we've covered this content up to this point. And here's what we're looking for. We need to set some environment variables. You can set them by running these lines in the console, but I like to make a .n file instead. So clear out the placeholders and replace them with your actual information. My seed phrase is just kidding. Don't share your seed phrase. But trust that I set it in my .n file, and don't forget to source your .n file after you make changes in it. We don't want to commit to GitHub, even in a private repo, so be sure to add .n files to your .gitignore. It's already in place for us. Now that we've got our environment variable set, get yourself some Rinkeby ETH. You can do that at a faucet. I already have some, so I'm not going to actually get some, but if you don't have any, now's the time. This faucet requires you to post your address to social media. I suppose it helps them avoid illegitimate requests. Now, let's go back and take a look at the contracts again. If you get done with this tutorial and can't wait to deploy Creature Factory or Creature Lootbox, take a look at the second file in the migrations directory. There's some code there you can uncomment and modify. But today, we're going to be focused on Creature, which is just a straight NFT contract. Its main job is overwriting the base token URI function that it inherits from tradable ERC721. We'll talk more about the token URI in part 2. Let's go back to the command line and get this party started. Okay, here we are. It's time for some action. Do truffle deploy -- network Rinkeby. That Rinkeby argument is going to tell Truffle that you want to deploy to the Rinkeby testnet and not to mainnet. Truffle's going to compile your contracts first. It will probably give you some harmless errors, or warnings, not errors. It'll do a dry run of the migration. Migration's a synonym for deployment here. The dry run tells you roughly what the cost will be for the actual migrations. And the dry run tells you the cost for the migration specific to the network. So this is telling us what it's roughly going to cost to deploy onto Rinkeby. The cost for deploying onto mainnet will be different. If we're only deploying Creature today, what is this migrations contract about? Why are we deploying it? Well, it serves a housekeeping function. It tells Truffle which migration script was last run so that you can save gas, but it's not a concern for right now. So the info we need from this console log is the contract address. And we can take that and go to Etherscan and verify that it was really successful by searching for that address. And if we see the same transaction hash and the same address, all of this confirms that this was indeed successful. So we've got a contract on the Rinkeby testnet now. We can also check out the events and see this first event here, which is me getting ownership of the contract. Okay, the next thing we need to do is update the .n file with our owner address, which is my address, and the contract address. Let's get the exact language right from the tutorial for this. Just grab these two lines and copy and paste them into your .n file, and then swap out my address and deployed contract address with the appropriate info. I'm going to do that now. And again, don't forget to source your .env file. I do source.env, but you can also do .env. I think they're identical. Next, we're going to run the minting script that creates the NFTs. Let's take a look at the minting script first, though. Okay, so there's a lot going on here, but let's just hit the highlights. Up here near the top, we're setting up environment variables. We also set a number of creatures that we're going to mint. Let's change that to 13, just so we know we're doing something. If you're missing any critical info, like a mnemonic or an inferior key, you're going to get a console log indicating that. We've only got a portion of the ABI here because that's all we're going to need to mint. Now here's the main function. This is what runs when we run the script. Different parts of this run depending upon what you set up. If you have a factory contract address, this bottom part runs, but we have an NFT contract address, so this top part's going to run. The first thing we do is create an instance of our creature contract. Next, we loop 12 times over it, or in our case 13, creating a new creature each time. We call mint2, and if everything goes well, we'll see a console log indicating our success and giving us a transaction hash that we can look up on Etherscan. Now let's run the minting script. After a brief wait for everything to get into gear, we're seeing the console logs that show us the transaction hashes of these creation events. Let's check one out on Etherscan. Okay, here we go. This is the record of the first token on our contract being minted. Okay, a few minutes later, we've got 13 freshly minted NFTs. On to the next part. Part 2, adding metadata. For purposes of keeping us out of a rabbit hole in this tutorial, we're going to be relying on an existing API that has all the metadata we need, prepped, compliant, and ready to go. But this section of the tutorial will take you through, of the tutorial docs that is, will take you through the requirements for building a metadata API yourself. If you're building your own metadata API, be sure to read this whole section closely, and drop into our Discord server if you've got questions. Here's the JSON for creature number 3. Let's take a look at how our contract makes this available to projects like OpenSea. Remember back in the creature contract we added this base token URI function? If you wanted your NFT to hit your own metadata API, you just use a different base token URI here. Let's take a look at the metadata itself. Each attribute has a trait type and a value in this case, but you can get away with just a value. Optionally, you can add a display type that will tell OpenSea how to display that trait. For traits with types of boost number, boost percentage, and number, it's important that the values are ints or floats, not strings. For the purposes of the dev tutorial, all of that's already been taken care of for us by the OpenSea Creatures API. However, if you're interested in making an API yourself, we have example Node and Python APIs for reference at the bottom of the page. If you'd like to see a tutorial on creating a metadata API, let us know in the comments below, and be sure to include your language of preference. Let's take a quick look at each of these APIs. So the action in the Python API is in app.py. It's pretty clever and pretty concise, but its heart is only 160 lines of code, and it's pretty readily understandable. Plus, they both have instructions that will help you get up to speed. The JavaScript API is even shorter, partly because it creates a little less metadata. We'd be happy to answer questions about adapting these APIs to suit your needs. Feel free to ping us in Discord or send us an email at support@opensea.io. We're always happy to chat. And if you're looking to make a bigger, more complex API, or give yourself the flexibility to update metadata on a regular basis, I'd recommend Django REST Framework. It's battle-tested, extremely well-documented, and well-liked by developers. It's actually what we use at OpenSea. Now that we've got a live contract hooked up to some ready-made metadata, let's see what it all looks like in the wild. Part 3. Viewing your items on OpenSea. Alright, let's see our work on OpenSea. First thing, let's grab the address from the console log. Now let's take that and go to rinkeby.opensea.io/assets, then paste in our address, put a slash, and then a token ID. Visiting a token's URL directly on OpenSea will populate it automatically, but it won't populate the rest of the tokens on the contract. If you change your metadata and want to update an asset, you can append force update equals true onto the asset's URL. In our case, nothing will change because the metadata API hasn't changed. The URL pattern for the API is similar to the pattern for the front end, but instead of assets, it's asset singular. Just like on the front end, you can append force update equals true onto the asset's URL to trigger an update. If you update your contract's metadata comprehensively, hit us up on Discord and we can update the whole contract for you. You can also validate your metadata by adding /validate onto the asset's URL on the back end. If it's valid, you'll get notice of that. If it's not, we'll provide an indication of what the issue is. Now that we've got minimum viable OpenSea presence, let's flesh it out. Part 4. Creating an OpenSea storefront. Okay, now let's use the getListed flow to backfill all of our assets. Visiting Boris McCoy's page directly makes OpenSea aware of the contract and one token. Using the getListed flow makes OpenSea aware of the rest of the tokens on the contract. Let's head over and plug in our contract address into the form. Depending on the size of the contract, this will take anywhere from a few seconds to many hours. If you get, looks like your contract is not ERC 721 compliant, make sure you're on the Rinkeby version of the getListed flow, and make sure you plugged in your NFT contract and not the migration address. When the process is complete, you'll be directed to your assets category page. On the category page, you can see some stats on your contract, some highlighted assets, and importantly, the More button in the top right corner. This button gives you a number of useful things. It gives you a link to your Storefront Editor, which we'll talk about later. It can provide you with a snippet of code that allows you to embed the marketplace in your site, and it gives you an interface where you can set up notifications in Discord. You can also access the More button on the contract's Assets page. So that's how to create a marketplace on OpenSea. If you've already got an ERC 721 compliant contract, it only takes a few minutes. Now that we've got a storefront, let's put some stuff up for sale. Part 5. Auctioning an item. For me, this is the magic moment. I created an NFT contract, and now I can instantly sell my items. I don't have to build a contract or anything. I don't have to get anything audited. I'm just instantly up and running. So in our minting script, we minted tokens to the owner address, which is us. So now that they're in my wallet, I can sell them on OpenSea just like any other NFT I own. And even before I create listings, OpenSea users will already be able to make bids on them. But anyways, let's hop over to the site and make a few listings. Let's start with a fixed price auction. Set a price, click Post Your Listing, confirm on MetaMask, and you're good to go. By default, fixed price listings don't expire, but you can set an expiration. Now, let's make a Dutch or declining price auction. To make a declining price auction, click the Include Ending Price toggle, enter an ending price, then pick a time frame. By the way, you can make a listing that's only available to one buyer by clicking the Privacy toggle and entering the buyer's address. But we're just making a general offering to the public, so let's toggle it back and post the listing. Now let's make an English or eBay style auction. You can change the default minimum bid and the default duration. Let's lower the minimum bid. And let's post this. Okay, users will be able to bid on this item, and in 5 days, the highest bidder will receive the item, and I'll receive the funds. If the auction ends without any eligible bids, nobody gets the item and the auction expires. That's it. Now, let's make a bundle. You can access the bundle creation flow by clicking Sell on an Assets page, or by clicking My Account and selecting Sell a Bundle. Let's add tokens 10 and 9 to the bundle. But before we post, let's scroll down to name the bundle. If you don't name it, you can't post the bundle listing. You can also add a description and a link if you want. And just like auctions for individual NFTs, you can create fixed price listings, declining price auctions, and English auctions. Let's make this a Dutch auction. Raise the starting price, set a low ending price, and set a duration of 1 month. Okay, sign the auction, and we're done. Okay, there we go. Now, let's list a creature for sale in an ERC20 token. On Rinkeby, the only option is OpenSea token, but on mainnet, you'll have more options, including DAI and USDC. You'll have to approve your token for trading to make a listing for sale in an ERC20, but only the first time. After that, you'll just have to sign the listing like usual. Okay, nice. Token 8 is now listed for sale in OpenSea token. And as I mentioned at the start of this section, by default, users will be able to make offers on these items, which you'll be able to accept from the Assets Detail page. And that wraps up part 5 and the end of our time on Rinkeby. Part 6, launching on mainnet. Take a deep breath, pat yourself on the back, and get ready to launch on mainnet. We're spending real money now, so be extra conscientious. The process for creating a mainnet storefront will be a lot like the process for creating a Rinkeby storefront that we covered in parts 1 through 5, so we're going to go through it a little bit faster. But first, let's pop over to ETH gas station to get a sense of the network conditions. If the network is super clogged, we might have to raise our gas price, but it looks like it's a nice mild day. 2 Gwei for standard is about as low as it gets. We could probably get away with even lower, but let's go check truffle.js to see what our setting is. Okay, we're configured to pay 5 gwei as a gas price, which is just fine for right now. Maybe a little bit high, but it'll do. Next, go back into your .env file and make the change from Rinkeby to mainnet. This might also be a good time to switch MetaMask from Rinkeby to mainnet. And don't forget to source your .env file like I just did right here. Okay, let's do truffle deploy -- network live. Okay, so after a little bit of time, we've got a successful deployment, and it cost just a little over 16/100ths of an ETH, which is around $20 at today's prices. Not brutally expensive, but I could buy a large pizza for that, so it's something I definitely want to get right the first time. So be conscientious about your contracts. Let's check it out on Etherscan. Looks good. Omitted here is the part of the video where I accidentally mint a bunch of creatures on Rinkeby because I forgot to source my .env file. So don't forget to source your .env file. Now, let's get minting for real. After a few minutes, we've got 13 fresh new mainnet creatures. And in the spirit of learning by doing it wrong, let's try entering the migrations contract into the get listed field instead of the NFT contract. It doesn't work because it's not an ERC 721 compliant contract. No harm done. Let's get the proper address and try again. Okay, now this is the right address. And this time, it works like a charm. Let's load them up. And there we go, that's fast. Looks like a lot like the Rinkeby version, except this is the real thing. Part 7, customizing your storefront. Let's customize this storefront. As I mentioned earlier, you can access the Storefront Editor from the More button in the top right corner of your contracts category page, and in the top right corner of your contracts /assets page. Let's see an example of those locations, and then let's check out the Storefront Editor. The Storefront Editor allows you to add a Storefront Avatar. I've got one ready to go. A storefront name, let's call ours Best Creature. A description, a URL. Let's use the developer docs URL for ours. And you can also set a fee on successful sales. Most developers that choose to set a fee impose a 2.5% fee on sellers. If you set a fee, be sure to add a payout address so that we know where to send your earnings. You can also choose a display style. Padded works best for most assets, but try them out and see what works best for your images. And be sure to click Save before you leave. Once the name change takes effect, which may take a few seconds, the old URLs will 404, and you'll have to use the contract's new name instead. So instead of OpenSea category creature v2, we're going to go to OpenSea category best creature. You can see that our contract name and the contract description have updated. And when we visit the asset detail pages now, we'll see the new info as well. And when users create a listing, they'll see a notice about your seller fee. Users will also be able to click an external link to access the item on your site, but that's set in the metadata, not the Storefront Editor. The link set in the Contract Editor is available below. And there's the dev tutorial page that we linked to. Part 8. Embedding your storefront in your own site. We're going to jump straight to section 10 of the tutorial because we've already covered the content in sections 8 and 9. Section 8 covers the initial item sale, which we covered back in part 5. Basically, just mint some items and put them up for sale. It also links you to the factory contract tutorial at the bottom, but that's for another day. Section 9 covers setting a developer fee on sales, which we just talked about in the last part of the video. So, let's talk about embedding. You can access the embed snippet in the More button. On top of your dev fee, you can earn bounties by making sales on your embedded marketplace. You can opt out by clicking the Earn Referral Bounties toggle, but claiming these bounties doesn't cost your users anything, so let's leave them turned on. You can embed the marketplace almost anywhere. To show how quick this can be, I'm going to embed mine in a Blogger post. I made a quick blog, now I'm going to create a new post. I'm going to give it a title, select HTML editing, and paste in the snippet. So the one twist here is that because of some quirk of Blogger, I've got to set a height to a pixel count instead of a percentage. But other than that, it's just copying and pasting. Now, let's check out the live marketplace. And here it is, with full OpenSea functionality on my own page. You can sort, you can do all the normal OpenSea stuff. You can also click into NFTs, see the detail page, buy, and since I own these already, in my case, I'll sell one. I'll sign this transaction and head back to OpenSea. And there it is. Boris McCoy, on sale for 1/10 of an ETH. That's how you embed your OpenSea storefront on your own site. I went with Blogger because it was quick, but you could do this with WordPress, Wix, on a site you built yourself. It's flexible. And that's it. You've made a marketplace and you put it on your own site. Congratulations. Back at the start of the video, we looked at the CryptoKitties marketplace for inspiration. Let's take another look at it now. To me, it seems way more accessible. With some creative content and time and effort, you might find your users selling assets back and forth to one another for hundreds of ETH each. And that's it. If you have any questions, please contact us. We're always happy to chat. You can find our email and the link to our Discord server in the description below. Thank you very much for your time and for your interest in OpenSea. We look forward to seeing your projects.